Can anyone help factor the denominator?
X minus 2 and x plus 1?
The sum is plus 1. The sum is plus 1. So it's x plus 2 and x minus 1. So x squared plus 2x minus x and minus 2. Do we agree?
Yeah.
Excellent. Can anyone identify the domain? We don't have to write it separately. We have to put it in the table though. Can anyone help with the domain? In plain English, everything but?
-2, 1.
Indeed. Very good. -2, 0, 1, infinity. Nothing. Nothing. The factors do not disappear. X equals -2 must be a VA, and x equals 1 must be a VA. Can anyone plug in 0 and tell us what happens when x is 0?
It will be -1.
Excellent. 0, 0, 2 over -2 is -1. Excellent. Can anyone tell us the end behavior and the horizontal asymptote for type 2? Type 2 is the easiest. The end behavior and the horizontal asymptote for type 2.
Y equals 0.
Exactly. Nothing to calculate. The only thing I need, the signs of the asymptotes. That's it, done. So I will plug in -2.1, -1.9, 0.9, 1.1. I'll put the function in the graphing calculator, punch in these numbers just to find the sign of infinities. It's not difficult if you put them in here, because this is negative, so this is positive. Or you punch it in the graphing calculator. Again, with -2.1, this is negative, and this is negative. So this must be positive. With -1.9, this is positive, but this is negative. With 0.9, this is positive, but this is negative. And with 1.1, this is positive, positive. That's all we need. Or you punch in the graphing calculator this function, and you punch in these numbers so you can find the sign. We don't need them for anything else. We're not going to plot them. We're not going to use them in any other way. I need numbers very close to the vertical asymptote to give me the sign of infinities. I need numbers very close to the vertical asymptote, 0.9 and 1.1, just to get the sign. I'm not going to plot something like this. I just need the sign of the infinity. And now all I need is my table. Nothing else is required to graph this function. When we graph functions with asymptotes, we have to start by graphing the asymptotes. They are not part of the graph, but they have to be graphed. This is an overkill. There is no need. But I don't want to forget. Then, oops, sorry, you cannot see this. Then I need x equals -2. And x equals 1. And now I'm ready to read my table from 0 to positive infinity. From 0 to positive infinity. 0 to positive infinity. From negative infinity, crosses at 0, 1. I'm sorry, 0, negative 1. It's coming from negative infinity. I doubt that it turns here, but we do not know in this class. We cannot find that out. So one option would be that it does this because it comes back to negative infinity. An option might be that it turns here. And another option that it turns here. I doubt. I think that this is the case. You chose the problem. We'll see. This is indeed, this is not part, we will not be able to know in this class. In the next class, we know how to analyze this situation. Okay, finally, from positive infinity to 0. That's it. Done. I have to write the function. We graphed 2 over x squared plus x minus 2. And now I will determine this as we determine the max-min in polynomials. And I'll show you how. There is no ambiguity here. There is no ambiguity here. None whatsoever. This is carved in stone. There is an iffy, tiny little iffy situation here. If it turns higher and crosses the x-axis, the y-axis. If it turns on the y-axis, I doubt. And if it goes to the right and then down, I doubt that too. So, with a graphing calculator, there is no reason to enter a y equals 0 because that is the x-axis. So now the function is 2 over x squared plus x minus 2. Right. X squared plus x minus 2. Good. The standard may be good enough or not. We'll see in a moment. So I'm going to still use the standard. I'm going to click on graph. I will not see the horizontal asymptote because it's the y-axis, the x-axis already. And it will not show the vertical asymptotes, but we know where they are at -2 and 1. Ready? So the function comes from approaching 0. Please do not copy something like this. It's not 100%. The function does not overlap with the y-axis, with the x-axis. It does not. So it gets closer and closer and then approaches infinity. On the other side of the vertex of x equals -2, it's coming from negative infinity. As I expected, it has a maximum on the left-hand side of the y-axis, and then we'll determine the maximum in a minute. And then it's coming on the other side from positive infinity to 0. These two sides are very clear. No ambiguity. Here we were not sure, and we cannot know this in this class. We need calculus for this piece. But we have the graphing calculator. So I'm going to say second in calc, as we did last time. I want to find the maximum. And I know the maximum is somewhere, do not enter -2 and 1 because the calculator will give us an error. So in this case, I just want to drag the cursor to the left a little bit, right there. That's my left bound. And then I want to drag the cursor to the right, right there. So this is what I'm asking the calculator to do. Dear calculator, in between this and this that I just selected, give me, I don't want to guess, give me the final answer. And it has to be an x to the left, which is a -x. It has to be a negative value because it's very clear that the maximum is obtained before the function crosses the y-axis. So it's at -0.5. So the maximum, I'm going to put it here, max, at -0.5, and the maximum is -0.88. 8, 9. So as expected, because these are also smooth continuous functions, this would have been very difficult for me to graph. This also would have been very difficult to graph. But this is smooth continuous. That's why I was expecting this to happen. If I have to twist my wrist to graph it, something is not right. Okay? We're going to have plenty more examples on Wednesday. We only looked at type 1 and type 2. We're going to have more examples from each. And we're going to look at the slant asymptote. The slant asymptote is why we study the long division and synthetic division. They are applicable in other situations.